Okay, so you got a, you should have got an email from me with a template for the midterm exam. There's something I wanted to talk to you about. This, I got immediately 3 texts about nothing to do with math, but the fact that this said start time at 10, end time at 12. That's irrelevant. I'm going to make 4 different versions of exams as I usually do, and it's going to have the start and end time for our class and the start and end time for the other class. So that's not something that's important. Math questions are more important because those you need to get resolved as early as possible. So I kind of just took exactly the template that they had used for the other 2, except I erased where they say you're not allowed to use the calculator. I will have Excel and Desmos up here, but not Mathway. So Mathway is not going to be used. And there's 2 reasons I don't want to use Mathway. Number one, it's a big pain. It seems to rely on the internet in a way that the other ones don't. And I feel like I'm standing up here half the time just trying to get Mathway up on a computer, and it's really annoying. The second thing is I feel like you guys aren't using it properly. Some of you are using it for things and then you don't know where your mistake is and spending all your time grappling with Mathway. Then you come back here to double check it on Mathway, and Mathway's down because of the internet. It's too much of a pain on both ends. So for graphing, you can use it, Desmos, and you can also use Excel. So both of those will be available up here to you. So you notice he has here, you must show your work completely and in clear steps. We as a class have not had that issue because we've had the rubric. So my question is, do we keep the rubric or not? I like the rubric because it really makes it so that everybody can see where the point allocations are. If you forget something, you can go back and look at the rubric and say, I didn't show that step, I can put that in. The bad thing, of course, is it also ties your hands. That means that there's no subjectivity at all. Everybody's got graded by the rubric. My concern is that someone will look at this on the outside and says, these students got it easier because they had a rubric. It's not, I don't think it's necessarily true. Do you guys feel the problems are easier because you have a rubric? It's not true. It's like the rubric's vague enough that I think that.
You don't want to do it, doesn't matter if the rubric's there, you're not going to figure it out.
So put the rubric in? All right, then I'm going to be taking the heat for that. Will do. So these are standard what we've been doing in the in-class assignments. On this type of question, you'll be given some work and you'll have to figure out where the mistake is procedurally, and you'll also have to be able to identify that mistake by looking at a problem that has, by looking at the graphs, the original graph versus the dashed graph, which is your derivative graph. So you'll be comparing the two and that literally pointing to it. Anything vague on there, I'm not going to accept. If I've got to sit there and figure it out, it's not good enough. Point to it and say, here's where the problem is. And that answer could vary from person to person. The person, you might find out that, oh, it didn't go through the x-axis where it's supposed to. That's fine. You may see that, oh, it's not above the x-axis where the original curve is increasing. That's a correct answer as well. So I'm not looking for one particular answer. It's like, can you look at this graph and amaze your kids one day because you can look at it and go, wrong. That's what I'm looking for, right? So can you immediately look at that and say something's wrong? And then, of course, once you know something's wrong, procedurally, you'll go back and have to look at that and fill in the gaps and then find the mistake. I don't know why Wilson Fisk is named by his last name and Matt Murdock has his full name, but good guys have their full name and bad guys have only their last name. That tells you who he is. He's a bad guy. Tangent line problem, very typical, graph the tangent line, the incorrect tangent line, look at it, examine, tell me why it's wrong. Is it leaning the best way to do that from what we did in class is to have the actual tangent line sketched in, not the correct tangent line using Mathway, but the actual, just eyeball and say, this is what it's supposed to look like. It's leaning a little bit to the left or it's leaning a little bit to the right. It's completely in the opposite direction. However you want to explain it. You want to explain that there's a gap and it's the slope where it's screwed up at. Or the y-intercept, I guess it could be wrong too. I felt like I had to add these questions because I looked at, our tests look very different. They're much more colorful in some way. So I thought this is such a boring setup with that title page on it too. That looks really scary. So I had to add some humor in there. So make something up, make me laugh. At least I'm grading and I'll have some fun. This is standard. So here's where the rubric becomes really important. If you recall, when we had sequence questions, I had a graph there, I asked you to fill it in, I had the table there, I asked you to fill it in, and then I asked you to actually do the analytical work. I'd like to keep that because it puts the space telling you that I want those things there. When I left those things out, you guys were using Mathway and you had that sign graph and it wasn't looking the way it should be looking. So you should actually have those things up there. And you should have learned for the in-class assignment from last time, pi is approximated. So whenever you have pi in there, it might give you some wiggling that's not real wiggling, it's an approximation. So you'll have to rescale your y-axis to really see if it's leveling off or not. So we did that in class. So those kind of things you'll have to see graphically. So I'd like to keep the rubric and the graphs the way we have them. Is that good? Okay. Is there anybody who doesn't want that? Okay, everybody wants that. So I'm just going to fill those in, very similar to the review sheet. I put sine pi and pi. I'm not going to put that on there because we already did it in an in-class assignment. But you get the idea. You'll have something there where you'll fill in. All right, on this one, you'll have to find a tangent line to a curve. I'll give you the x coordinate only as usual. I think everyone in here knows how to do this, which is really good. That's kind of the criteria they use in the regular Calc 1 class, that if you don't know how to do that, whoever taught your class really failed. So everybody should know how to do that coming out of here, because that's the whole point. You're taking a curve that's going up and down and you're approximating by lines. So graphing the tangent line, if you get an error here, tell me the truth. Say you got an error. It's fine. You get credit for that. That's what I'm looking for. I can't expect everyone to be perfect. You've seen me on the board. I'm not perfect either. And no mathematician in this whole universe is perfect. They've all made mistakes. But can you at least look at it and say, I did make a mistake? And given enough time and given a different setting, I could probably hunt it down. That's the skill you need to have. So for me, that's really important. So just tell the truth. Don't try to force your answers to match up. And then this one gave some trouble, so I'm going to do some of these problems today so you can see them. This is what we call the limit definition. Georgia Tech students and West Point students call it doing the derivative the long way, because they consider it, oh, my teacher Fred showed me a short way, you know, with the power rule. It's not really that. It's not really a short way. This is actually the real way. And when everything erases and you don't know what you're doing, this is the way you're supposed to do it. Take 2 points, connect the dots, find the slope between those 2 dots, take the limit. That's what you're supposed to do. So that's what this is. I'm going to go through a couple more problems so you can see how to do that. I gave one problem up on YouTube the other day because a student was asking, how many of you saw that video on YouTube with the square roots? Was I talking really fast? I had kids and my husband all in the same room, and I was like, please don't belch. Please don't make a noise. Let me get through this really fast and get this up there before something really embarrassing happens. So I was trying to, that's why I was speaking really fast. Hopefully I can slow it down a little today. And this one also is a 2-for-1 for me. I like 2-for-1 problems. I erased like half the problems that they had on their midterm if it's assessing the same thing. So I can ask 2-for-1 here. I can ask you to find the limit of rationalizing the numerator right here, because it's a 2-for-1. It's a tangent line problem and a finding the derivative and everything all rolled in one. So that way I'm not giving you 100 problems to do. You'll have plenty of time to take this test. And then I have 2 other add-ons here. Verify using the short way, as the kids call it in engineering schools, taking the rules and taking the derivative, that you actually get a matchup. And then finally, graphing. Graph the original, graph the derivative, and see if they match up. So Dr. Golnabi and I had a good conversation about what's needed in this for you leaving here. And he said if he had to do it over again, he would do a lot more graphing. That is the skill you need walking out of here. And I really want to lift off on the second half of this semester so that we're doing only applications to real, like, diagnosing diseases. How do you do that? In the second half of the class, I'd like to teach you those kind of laws instead of focusing on transforming so many different things that you'll never see that. We should probably look at the MCATs too and see what kind of math is on that, just at the end, just to make sure that we'll take a little peek. Maybe at the end of the content, we'll take a look at what content on math is on the MCATs. Don't you have to take the MCATs?
I already took it with power rule.
Well, a free MCAT session. We'll look at strategies maybe to look at those problems, because they're multiple choice, are they not?
Yeah, the whole thing.
And it's super fast, isn't it?
Yeah.
So we have to figure out strategies. You can't do like the Dr. T, think deeply about it, you know, draw your graph, none of that's going to happen on the MCAT. So let's do a little bit of MCAT session here at the end. What do you have to take for PA? We have a lot of PAs. Same thing? MCATs? You have your own test? GRE? So let's pull a couple, like the math portion of the GRE and the math portion of the MCATs, and start looking at some of those problems just to review and refresh. If you have any other standardized exam that you're supposed to take for your discipline, let me know. And then this one is the one where you have the broken up pieces of the graph. I'm not so sure that's important, but it's there. And that's it. It's a short test. I can ask a lot of 2-for-1s in a lot of the problems. Are there any questions about the test setup? Yeah, that's the limit stuff that we're doing. Sliding the a to x. Do you remember all that? Yeah, that's that limit stuff. It'll seem easy when you look at it now. You'll look at it and go, why was that so hard before? Okay, another question?